Hello, welcome back. Today we're going to continue our discussion with the fundamental theorem. Remember the FTC. Today we're going to incorporate our substitution technique that we talked about a few days ago. Recall from yesterday that the FTC says if we take the antiderivative of a definite integral, to get the area under the curve, we just look at the difference in the values of our function. And so let's go ahead and start this. So we're going to apply the FTC with use substitution. Except this time, the only difference is we're also going to have to replace our domain. And the reason for that is because our domain is also going to be in terms of x. Oops, can't spell the word of. There we go, of x. So we're going to solve it the same way we did the other day. So we're going to use our use substitution. And when we talked about those, we mentioned the idea that this is a composite function. I know it's a composite function because x is inside of something and it's not alone. So when we integrate this one, we're going to use our u. Our u here is going to be this x squared plus 1. And our derivative is going to be 2x dx. And solving for dx, we get du over 2x. We've been doing that for a few days, so this should be old hat for us. Now, our next problem that we have to do is we're going to have to change our domain. And the reason we do that is because our domains are also in terms of x. So to change the domain, my first x is going to be 0. We start at the bottom. If x is 0, to get u, we're going to plug it into our equation. That's why this is a very important formula for us, this u equals x squared plus 1. That's going to give me u squared plus 1, or 1. When x is 1, u is going to be, same thing, 1 squared plus 1, or 2. From here, I can now rewrite my integral. It's going to be x u cubed du over our 2x. And our domain, our old domain went from 0 to 1. Our new domain is going to go from 1 to 2. We changed it. Now don't forget, these x's better cancel out. They have to cancel. All those x's have to cancel. And I'm going to go ahead and rewrite this just to make it look a little bit nicer. From 1 to 2, remember this 2 is on bottom, so that's 1/2 u cubed du. And we could integrate this one really quickly. We get 1/2 times u to the 4th over 4. And from yesterday, we said we're going to evaluate this. This is 1/8 u to the 4th and we're going to put this little bar here that says we're going to evaluate it from 1 to 2. Remember, we don't need a plus c for a definite integral because it's going to cancel out. And we saw that in yesterday's video, so you can watch that video again if you can see that. Plug in. We're going to get 1/8 times, this becomes 2 to the 4th, minus 1/8 times 1 to the 4th. And we shouldn't leave 2 to the 4th. We should know what that is. This is 1/8 times 16 minus, and again, 1 to the 4th. 1 to the 4th is 1, so minus 1/8. And if you want to clean this up, that's just 15 over 8, but that's okay too. We typically want to simplify easy exponentials like that. So let's try another one here together, and then we'll let you guys try one on your own real fast. So number 2 here. Again, this is a composite. Look for your inside function. There's u. That's my inside. U is always inside of a composite. So when we find our u, we're going to get 3x cubed plus 3. Our du becomes 9. Whoops, that looks awful there. Our du becomes 9x squared dx. So we get dx equals du over 9x squared here. Now, again, I'm also going to replace my domain, because remember, these are in terms of x's as well, so I want to replace these as well. So my first domain says x is -1. To get u, we plug it in. We get, this is going to become, oh, hello, nurse. Let me see that. We plug -1 here, this becomes a -3 plus 3 So that's just going to become 0. I'm just going to do it in my head. When x is 0, plug 0 in. This just becomes 0 plus 3, which is 3. So now I can write my new integral. It's going to be this 18x squared. We can replace that or cancel it, times u squared du over, and this becomes 9x squared. And my new domain from 0 to 3. We're going to replace our domain. Whose domain? Domain. The x squareds will cancel. And if you want to simplify, this is 18 over 9, which is just 2. So I can write this as just from 0 to 3, 2 u squared du. Now we have to do the FTC step. And remember, the FTC says we are going to evaluate the difference in the values of our function. So we have to integrate. Remember, so this is my derivative here. So we have to integrate, and that's just as 2/3 u cubed, and we would evaluate that from 0 to 3. And like we said yesterday, you're really going to like zeros in here for the most part. Not grade-wise, of course, but 2/3. Plug your 3 in. This becomes 3 cubed minus just 0. And again, we shouldn't leave it as 3 cubed. 2/3. 3 cubed is 27. This is okay to leave, or you can simplify it, and I believe it becomes 18. So go ahead and pause the video if you need to, and try number 3 real fast, and we'll go over in just a minute, okay? So for number 3, we're going to let u again be our inside, so we get u equals x cubed plus 8, our derivative 3x squared dx, giving us dx is du over 3x squared. Right, like that. So replace your domain. When x is 0, remember this is my x, you plug the 0 in, we get 8. And when x is 1, plug 1 in, we get 9. 1 cubed plus 8 is 9. So I can rewrite my integral from 8 to 9. We get x squared times u squared du over 3x squared. Whoops, should be x squared there. Now again, those x squareds have to cancel. If not, we did something wrong. Cleaning this up a little bit, we're going to get from area from 8 to 9, 1/3 u squared du. Integrating it, we're going to add 1. We get 1/9. And you can do that real quickly in your head. That's just 1/9 u cubed. Again, we don't leave the plus c here because it's canceled out. We saw it in the video. If I did the plus c, we would just be adding c and subtracting c. I'll show you that in a second here. So we're going to go from 8 to 9 using the fundamental theorem, FTC, f of 9 minus f of 8. We get 1/9 times 9 cubed minus, minus 1/9 times 8 cubed. So let's talk about what happens at c. Remember, if I put a plus c here, there's going to be a plus c here and a plus c there. Notice we're subtracting and they're the same constant, so they would just cancel out. So we just don't worry about those. And there is our answer. I don't expect you to know what 9 cubed or 8 cubed is, so we're good with that. So let's take a look at number 4, and then we'll take a pause on this. For number 4, again, I'm going to rewrite this. I don't like my powers on the bottom there. So I go 1/5 x, and I can write this as 2x minus 1 to the negative a half dx. There is my inside, and that's my u. It's composite. So we get u is 2x minus 1. du is 2 dx. So dx is du over 2. Now we are going to recognize a problem here really quickly. Changing my domain, when x is 1, u, plug 1 in, we get 1. When x is 5, u is 9. Now watch what happens when we plug in now. Uh-oh, this is going to become problematic for us. My new domain is from 1 to 9. Let's see if you can figure out what's the problem here is. We get 2x minus 1 to the negative a half. Whoops, sorry, we replaced that. That's definitely a problem right there. We replaced that one. This becomes u to the negative a half du over 2. Notice the x doesn't cancel. We have to use our algebraic substitution here. And we can solve up here. We can say x is equal to u plus 1 over 2. That escalated quickly. So if we write this 1 over 9, I can write this as u plus 1 over 2, u to the negative a half, du over 2. These two is on the bottom. That's going to give us a 1/4, and I can distribute the u to the negative a half. And that's going to give us u to the 1/2, because that's a 1 there, plus u to the negative a half du from 1 to 9. And now we're finally ready to take the antiderivative. Adding 1, we're going to get 2/3 u to the 3/2. You can verify that. Plus 2 u to the half. And we're going to evaluate that from 1 to 9. So how to write this answer? We're not interested in cleaning it up. We just want to get an answer. So we do f of 9 minus f of 1. We don't have to put our x's back in. Remember that. We're already replaced. We don't have to put our x's back in because we substituted in our u's. So once we do that, we're done. So plugging this in, we're going to get 1/4. I'm just going to write some really super large, big fraction. Keep the 1/4 on the outside. Plug in the 9. We get 2/3. 9 to the 3/2 minus 2 times 9 to the 1/2. Plug in the 1. Same thing. That's just 2/3 plus 2. And we should clean this up a little bit. We really don't like 9 to the 3/2. So if we did this, we would get 1/4. This becomes 2/3 times 27 minus 2 times 3 is 6 minus 2/3 plus 2 in parentheses. And there's a final answer. See something like this, just run this genius level. Work right there. All right, hope you enjoyed these video. Come see me for part 2. We'll finish these up.